What if the hills you see while cycling in virtual reality do not match reality? In this work, we explore how far virtual inclinations can deviate from real inclinations before cyclists notice the mismatch. In virtual reality experiences, mismatches between reality and virtuality are usually considered undesirable, as they can disrupt immersion and induce cybersickness. But if carefully controlled, they can be used positively to expand the design space of VR. To investigate perceptual thresholds, we designed a custom simulation. Participants cycled on an indoor bike that tilted between minus and plus 15%, providing real physical inclinations. At the same time, they experienced virtual inclinations in a simulated city, ranging up to minus and plus 65%. These can be perceived through houses, trees, and street lamps providing horizontal and vertical lines, the horizon line, and a mountain in the background as fixed references, and shadows reinforcing depth and slope. To measure perceptual thresholds, we followed a one-alternative forced choice design with a symmetric question. Using handlebar buttons, participants judged whether the virtual road appeared too steep or too flat. We applied an interleaved multiple staircase procedure to determine the upper and lower thresholds, the points where mismatches between real and virtual inclinations become noticeable. Our study with 30 participants was split into two counterbalanced parts, measuring upper and lower perceptual thresholds across 7 real inclinations from minus to plus 15%. Each part was followed by questionnaires assessing perceived load. Our results show that cyclists can easily be led to perceive steeper uphill or downhill inclinations than they physically experience, without reliably noticing the mismatch. The strongest effect was for downhills. Real inclinations of minus 15% still felt congruent with virtual slopes as steep as minus 50%. For uphills, plus 15% in reality could be paired with up to plus 31% virtually. Analyses of correlations with demographics, prior cycling and VR experience, cyclists' posture, and subjective load did not reveal significant effects. Interestingly, we also observed systematic perceptual offsets. When cycling at a physical tilt of minus or plus 15% and viewing the same inclination in VR, many participants judged the slope as insufficiently steep, suggesting that in VR, reality itself is often rejected. These findings provide the first empirical estimations for perceptual detection thresholds of real to virtual inclination mismatches during cycling in VR. They show that perception can be deliberately manipulated within a congruence window to enhance VR experiences. For example, in training systems, a virtual downhill could motivate tired cyclists, while in exergames, mismatches could add challenge and excitement, extending what VR can simulate. This opens new opportunities to deliberately leverage perceptual mismatches in VR cycling.